I'll present my, I'm a PhD student from University of Southern Denmark. I Center for Energy Informatics. I will be presenting my PhD project entitled Analysis and Application of Multiple Control in Energy Systems. So to some background of my PhD project, my project focuses on saving energies, and it has been spotted that buildings and industry sectors are large energy consumer and also release a large amount of CO2 emissions. In this regard, it is extremely important to increase energy savings for both sectors. Our approach will be using advanced control strategy, particularly the model-predictive control. So what is multiple control? I will give an example for the building MPC, the multiple control application in buildings. Consider that we are trying to regulate the temperature in the building and at the same time save energies. As indicated by the name of multiple control, we will lead a predictive model, which is also called the control model. And this model can accurately capture the thermodynamics of the buildings for a given optimization horizon of 24 hours. For instance, at current time step, the control model will predict the building indoor temperature for the next coming 24 hours. The optimizer will use the control model and constraint together with constraint cost function to formulate an optimization problem. The MPC optimizer will output the optimal control sequence to the actuator, which in our case will be the HVAC system for the coming 24 hours. But instead of applying all the control sequence for the next 24 hours, it will only apply the first time step, which will be 1 hour. And at the next time step, the measured temperature from building will feed back to the optimizer, and the optimization will repeat. So basically, the characteristic of MPC will be as a predictive model, a rolling optimization, and a feedback correction. Why are we using the multiple control? So to mention the benefit of multiple control compared to the conventional control strategy, such as PID controller. If we are using the PID controller, the system will only react when it reaches the unexpected condition. But for a multiple control, since we have a predictive model, we are able to predict the further future states, and the system can react in advance to avoid the unexpected conditions. This makes MPC extremely good at dealing with large scale of energy systems with thermal inertia, such as buildings, big scale of thermal storage tank, and other industry energy systems. In general, MPC implementation can be divided into 5 steps, starting from developing of control models, defining cost function, selection of the optimization techniques, and end up with testing and conditioning of MPC. In these 5 steps, choosing a proper control model and optimization techniques, these 2 steps are kind of hard, and they are normally chosen according to research experience. This fact will bring up the research question for our project. Is it possible to find the best optimization techniques that for given type of energy system model? To answer this question, we need to know the status of the research, the state of art. What is the research status of MPC in combination of optimization techniques? Here we present a state of art for one typical energy system, which is building MPC, rather than covering all the MPC application in different energy systems. In regard to building control model, it falls into 3 different categories: white box, green box, and black box. Where white box is built based on the physics and of the system. Black box built purely based on the statistical data, while the green box as approach combines those two functions. The green box model will be is actually the quite the commonly used control model for multiple control, and in particular the RC network model, which is a resistor capacitor thermal network model for buildings, is quite commonly used. Here is a picture of different of RC network of different orders. As for the combination of MPC models with optimization techniques, basically the literature shows that they use for the research study, they use specific MPC configuration applied in specific building energy systems. And there is still a lack of leading guidance on which MPC configuration will prefer the best in general. And these facts will result in slow transition between the wide research activity in academia and the real implementation in industry. The picture here covers all the aspects need to consider for building MPC. Researchers has done a lot of work on different branches. However, in regard to the models and algorithms optimization techniques, there is still something missing. A systematic study on the combination of the models and optimization techniques is still missing. So to answer our research question, we will investigate 3 case studies for our project. To start with, we will do first the building MPC. Basically, first of all, the literature study, a comprehensive literature study will be done to map the model, control models, the optimization techniques, and their combinations, and also include the possible available KPIs for performance assessment as well. Next step will be developing a building virtual testbed that enable us to make numerical experiment on. We will use this virtual testbed to test metrics of number of model type and optimization techniques, and compare the performance using different KPIs. Following this step, a real MPC implementation in a real building will be carried out. With the help of the 3 steps here, we expect a comprehensive methodology on how to choose models, and the corresponding optimization techniques will be formulated. This methodology will be further applied in other 2 case studies, such as greenhouse and district heating networks. So until now, one may ask, do we have already a building virtual testbed available to make numerical experiments on? The answer is yes. So in SDU, we have a Python-based package called AppShoot available, which is an open source framework for multiple shooting MPC in buildings. Under this framework, we can supply different control models and define our different optimization techniques for solvers, and do the MPC simulation under this framework. In order to test our models, the modeling approach for our control model will be using the modeling language. We mainly develop green box model using the RC networks. And since it's a green box model, we need to identify the system. And in our center, we have another available package, a Python-based package called Modify, that allow us to do the parameter estimation. Now I will show a demonstration of using this framework in an office building for building MPC. The office building is located in our university, Denmark, and it is equipped with a radiator heating. And also we have a bunch of sensors collecting different data, such as the window opening status, the indoor temperature, and the radiator temperature set point. We built we built an RC model for the office building, which is showed here. And this model is developed in Daimler with the input of solar radiation, outdoor temperature, occupancy, existing information, window opening status, and temperature set point for the room. And the model will output the indoor temperature as well. At the same time, it will compute the heat consumption for the room. This green box model contains a set of unknown parameters, and we will use data collected from the office to do the identification. The system identification is performed. The model is trained for 5 days and validated another 5 days, taken from the measurement of the office. We are using the modify package, which is the generic algorithm to identify the system. The identification validation result is showed on the right figure, and basically the validation result shows that the simulated indoor temperature matches quite well with the measured indoor temperature, and which means that the identified control model is quite accurate in terms of capturing the office thermodynamics. Now the control model is available. We was subject to the MPC simulation with MShoot framework. We try to minimize heating supply, while we have to the optimization has subject to the system dynamics and also the maximum the constraint for the heating maximum heating power and the indoor temperature constraint. The 5-day MPC simulation result is showed here. We will also compare the MPC with a role-based controller to show the performance, and it can be seen that here the MPC will preheat the room in advance to avoid thermal discomfort, and this will result in less energy consumption compared to role-based controller, and at the same time less thermal discomfort. So just to mention that the demonstrated virtual testbed can accept different control models and optimization algorithms, which actually enable us to systematically test the matrix of control models and optimization techniques. But there is also some other platform or framework available, applicable, except to MShoot. For instance, there is one ongoing project, EPIPSA project 1, which I am partially involved in, and under this project, one of the subtasks is to develop building performance, a framework for simulation-based testing of advanced control strategy in buildings. And to summarize is the PhD project. Basically, our goal is to develop a methodology of finding the best models and optimization techniques combinations for MPC application in different energy systems, and with the help of MShoot or as the Bob test, and we hope the goal will be achieved. And the contribution of the project, the PhD project, will be speeding up the transition between the intensive MPC research activities in academia and the real application in industry. Thanks for your attention. That's my end of my presentation.